Hi and welcome to video 6 on this series on forces and motion with relation to differential equation, Unit 4, Topic 2 of Specialist Mathematics. So we've got two more examples from simple harmonic topic to go here. We've done the previous example and we've talked through the basis and the theory in a previous video, so you may want to go back and visit that. But let's have a look at example 2 for now. A particle in simple harmonic motion, that's my lazy way of saying simple harmonic motion, is moving with a velocity at 1.8 meters per second as it passes through its central position. When the particle is 0.6 meters from the central position, it has an acceleration of 2.4 meters per second squared. Calculate the amplitude of the oscillation and calculate the period of oscillation. So this is a bit tricky and I don't really know where to start necessarily, so I'm going to start by writing down the things that I know. So I know first of all that the velocity is equal to 1.8 meters per second. So is this at the start? Well, it doesn't say anything about time, but it passes as 1.8 meters per second as it passes through the central position. So therefore at x equals 0. I also know a displacement, of course, displacement and acceleration relationship. So I've got acceleration is 2.4 meters per second at x equals 0.6 from the central position. Now you notice here the link between acceleration and displacement is always that negative omega omega squared x. And in this case, a and x are both positive, but we don't really know much about this x value in particular, or really the a value, because it's not usually denoted with that direction. And x, we just know it's 0.6 meters from the central position. It could be negative 0.6 or positive. So we're going to use that fact and that feature as well. So we're asked first of all to calculate the amplitude of oscillation. So what we do know is we know the value of a at a certain x value, and we also know the value of v at a certain x value. But this first one here gives us a fair bit of information because we know that a is equal to negative omega squared x, and so therefore 2.4, which 2.4 here, is equal to negative omega squared times by negative 0.6. So I'm going to assume the acceleration is positive and the displacement is negative here. Dividing through, I've got the positive obviously, so I get omega squared is equal to 2.4 over 0.6. How many 0.6s in 2.4? And that's 4, and therefore omega is equal to 2. And we'll stick with that positive version there because again, this is the measure that's related to period, and the period we want it to be positive. And it's really irrelevant which way we go. So I've got that positive 2 value, and if we do need the period, which we do incidentally, that will be equal to 2 pi over pi, but we'll get to that. So part A, I've used this. Usually we'll use 1 point for each unknown that we find. Now I need to use this second one here. So I'm going to use this formula. V squared is equal to omega squared times by a squared minus x squared, because I have a known coordinate x and v, and I know that. So I'm going to put in my known coordinate. 1.8 squared is equal to 2 squared a squared minus 0 squared, which is nice. That means that a squared is equal to 1.8 squared over 2 squared, which is also nice. I can take the square root of everything, and a is equal to 1 over 2. So a is equal to 0.9. That's our amplitude. But of course I took a square root, so it's plus or minus 0.9 again, but I'm going to stick with the positive amplitude because again it doesn't matter, it will just affect the eventual phase shift if I get to that far. So 0.9, and then part B asks us to find the period, and t is equal to 2 pi on omega, and that's 2 pi on 2, which is equal to pi. And this is given to us in seconds, so pi seconds is our period. And of course our amplitude is given to us in meters, so we can write down 0.9 meters. So there's example 2, and now I'm going to run through one more example which is from an external exam that's been provided for us. So this example says a particle P moves with simple harmonic motion and comes to rest at 2 points. A, there, which are 0.24 meters apart on a horizontal line. The time for P to travel from A to B is 1.5 seconds, The midpoint of AB is O, which is the center of motion. If you're ever given that O, it's almost always the center of motion. At time equals t, P is moving through O towards A with a speed of u meters per second. So it's exhibiting simple harmonic motion, but we're not given the exact details of what type of simple harmonic motion. So what I'm going to do is I'm going to represent this on a straight line, just as a diagram here. So we've got A, we've got O, and we've got B. It's important to note here that we've got 0.12, 0.12, and that gives us our A and B are 0.24 meters apart. And of course we're told that O is the midpoint of AB, so that makes that 0.12 work. And initially at time equals 0, the particle is here and it's heading towards A. And so it might be in fact easier for us to think about A and B the other way around. And so sometimes you just need to draw out your diagram and start to plan what's going to be the easiest to deal with. We know that at time t, P is moving through O, so the displacement is 0, but we also know that the velocity is maximum, so u will be the maximum velocity. So let's find the speed at x equals 0. That's our first task. A, find v at x equals 0, which also happens to be when t equals 0. So working through this, we know that v squared is equal to omega squared times by a squared minus x squared, but we've got x equals 0, and we're trying to find v. We'll call that u. U is equal to the square root of this side, which is plus or minus omega times by the square root of a squared minus 0 squared. So this is nice, it's plus or minus omega times a, and that's our u value. But we also know that this particle comes to rest at points A and B. I'm sorry, that's going to be funny. At points A and B. So it's actually indicating that these 2 points are our end points. And there's an extra piece of information we need to take in mind. So that means that the particle goes between these 2 values. And that means our amplitude, A, is already known. A is equal to 0.12. So we've got some information there. Now we also know that omega is the angular speed. It's theta over t. So simple harmonic motion leads us to that. We also know that it takes 1.5 seconds for this particle to get from A to B, which means that the total period t is equal to 3 seconds, which means that omega is equal to 2 pi over 3. So we've got A and omega, and we can therefore say that u is equal to plus or minus, and we'll get to the plus or minus component in a minute, but plus or minus 0.12 times by 2 pi over 3. And so now we just need to go ahead and simplify that value, and the best answer that we can probably put for it is 0.08, I think 0.08 pi, but of course we could write that down as about 0.251 meters per second. Now I've made this positive because initially it's traveling towards A, and actually it's the way that I've incidentally made my diagram that traveling towards A is a positive. So it doesn't really matter, but let's say that we just make it positive to make life a bit easier. So now we're going to talk about part B. I'll do part B over here. Find the distance of P from B when time equals 2 seconds. So I know my value for omega is 2 pi on 3. I know my A is equal to 0.12, and I know that alpha is equal to 0 because we're told it starts at 0. And so if it's starting at 0, at time equals 0, P is moving through O, then I'm going to use a sine function and alpha equals 0. So this is where we're considerate about which function to use. And so therefore, x is equal to 0.12 sine of 2 pi on 3 times by t, but we've got t equals 2, so it's 0.12 sine of 4 pi on 3, and sine of 4 pi on 3 is equal to negative root 3 on 2. So it's 0.12 times by negative root 3 on 2, which is something crazy, but we can write that down as negative 0.06 root 3, and this is from the initial point, but B is in the negative, so the question says find the distance of P from B. Well, B is 0.12 away, so therefore the distance is 0.06 root 3 towards B, or the distance from B, which I'll just write down from B, is 0.12 minus the distance from O to B, which is 0.06 root 3. And that'll be the overall distance away or towards B it is. So there's the answer to the first one. I'm just going to leave that exact. So that's part B. And then part C, our final part is find the speed of P when t equals 2 seconds. So this is a fairly simple question. We've got two options. We've got x dot equals d dt of x, do a bit of calculus, substitute in, or we've got this one, v squared equals omega squared a squared minus x squared. So we've got two options if we want to use them, and of course we know the x value there, but let's go through and do this x dot dx dt if we need to. Oh, this is probably the wrong angle, by the way. It's this one here. That's the x value of that coordinate. So x dot is equal to the derivative of our function up here, and so that will be 0.12 times by 2 pi on 3 times by cos of 2 pi on 3t. We're going to put in t equals 2, so that's equal to 0.12 times by 2 pi on 3 times by cos of 4 pi on 3. 4 pi on 3 is, as we've done up here, it's in the third quadrant because it's a bit more than pi. It's pi on 3 in the third quadrant. Cos is negative, but it's negative a half. So equal to negative 0.12 times by 2 pi on 3 times by negative, so I've already included the negative, times by a half. And so that's equal to half that, pi on 3. So it comes out as negative 0.4 pi, or approximately negative 0.13 meters per second. So that's our speed at that point, and you can see why it's negative, because at that time it's heading towards B. It's got a bit crazy and drawn down here. So there we have it. That's our simple harmonic question. That's from an exam. It's about as tough as they come for these questions. If you know the formulas, or you can derive the formulas, you can do most of this stuff. But you do have to be careful. You see that I've just plotted around these. But it's just these little things like this where you just got to make sure you don't forget the chickens. It's not asking for the distance from O, it's asking for the distance from B in those calculations, and then making sure you get your negatives right. All the best.